A rectangular box has to be made with the width being twice as long as the length, with a bottom but without a top. If the surface area of the box is 400 centimeters square, what is the height of the box with the largest volume? So they give us a rectangular box. So your box look like this. Here's our box. So we have bottom but without the top. So we don't have this area here, but we do have the sum on the other side, area of the other side. So they give us the surface area 400 centimeters square. So let me denote this on the length by say L. The width, they give us the width is 2 times twice long as the length. The height. Now we need to compute the surface areas. You have the surface area of the bottom here. It is a rectangle. So this side is the width, this side is the length, so the area of the bottom, let me call it B or bottom. Length times width. Width is twice length, so length twice length times length, 2L square. We have the two sides, this side and this side of the same area. So area of the side, let me call it star. Star. Area of each of one star is the length times the height. The length times the height. We have two of them. And we have the area of the front and the back. So the front is this one and the back is here. Area of front equal to area of back equal to the height times the width. The width is twice long as the length. Height times width, height times 2L. So area of front and the back is 8 times L. Now let's compute the total surface area. The area of the bottom, 2L square. Area of each star, so 2 that. 2 length, height. Area of front and back. The front, 2 high, length, with 2 of them front and back. So this is 2L square, 2L8, 4L8, 2 length square, 6 length height. Surface area 400 centimeters square. This gives us a relation. I can divide it by 2. Length square, 3 length height, 200. So remember that we have length, height are on positive. Length, height, positive. For the relation, let it be here. The question asks us what is the height of the box? What is the height of the box with largest volume? Let's compute the volume. Volume, length, width, height. Volume, we call it V. Length, width, height. Length, width is twice length and height. And actually we can rewrite length in terms of height or height in terms of length. And this formula, height, can be easily written in terms of length. So I do that. Because of this formula, we have length squared plus 3L, 3 length height equal to 200. 3 length height 200 minus length square height 200 minus length square over 3 length. So plug in here, height equal to this one. So this gives us volume. Volume equal to, volume here is 2 times length square times height. 2 times length square times height. 2 times length square times height here. L square divided by L. 2 times length 200 length square over 3. 2 over 3 200 length cube. This is our volume and this is a function in length. So remember that we do have the condition. We need to check the condition on the length here. So let's see, length positive. We also know that because height is also positive, so this one is positive. So set up the interval for the variable here, in our case length bigger than 0, height is bigger than 0, which makes 200 minus length square bigger than 0. Length square smaller than 200. Length is positive, I can square root both sides. This is our domain for the length. And this is a function. What we need to do is that we need to find the values for the height or for the length so that this one is maximum. So we want to find L and height. The question asks us such that VL is max. So L between 0 square root 200. Now this function is continuous on this interval. Compute the derivative. V prime 2 over 3 200 minus 3 length square. So we can bring that 3 out. 2 over 3, and I have 3 200 over 3 length square. So 2 times 200 over 3 length square. Factor is as square root 200 over 3 minus length 200 over 3 plus length. So these terms equal to 0. We want critical point. This one is always positive. So V prime L equal to 0 if and only if these terms is 0. If and only if length 200 over 3. Square root of that. This gives us, can bring that 100 out. So 10 square root 2 over 3. I will do this later. For now, just keep length like this. Now we need to see the behavior of the function. Length between 0 square root 200 and then our length is this one, the critical point. V prime length 0 here. V prime length equal to this when length smaller than this one, so this term's positive, so length smaller than this, so on this interval V prime positive, so positive here, negative here. V length increasing, decreasing, and therefore the maximum is here. V length is max when length is 10 square root 2 over 3. They ask us to find height, they don't ask us to find length. So I can find height. Height equal to this formula. Length square, this one square, 200, but that one square equal to 200 over 3. 200 over 3. 3 length times 10 square root 2 over 3. Numerator is 200. 1 minus 1/3. So 3 10 square root 2 over 3. So this is 200. 2 over 3. 3 10 square root 2 over 3. So 200 10, so I can do 20 there. 3 still there. Square root of this one over square root of this one, so we have square root 2 over 3. 20 over 3, 2 times 3, 3 times 3 to get rid of that square root down there. 20 over 3, square root of 6 over 3. 20 square root of 6 divided by 9. This is our height. The height is this one, and at that height, the box has a maximum volume. Our final answer is here.